Okay, so what I'd like to show you is how you can design and simulate a logic circuit using Quartus Prime Lite. This is a really good tool with a really good simulator, and it's good for designs for schematic capture as well as a hardware description language. So let's get started. So the first thing that you want to do is actually download the software. So if we go to, you could just Google it. You could type in Quartus Prime Lite download, and this will come up here from our Google search. And this is the website here. And so this is the Quartus Prime Lite edition, and you want to get the Lite edition because there's no license required and it's free to download. So you want to select edition, so you don't want pro or standard, you want to make sure it's light. And I'm just, have the latest, they're up to 19.1 for the version. And you can do either Windows or Linux. I'm going to leave it at Windows. And I'm not going to actually download the software at this time, but I'm just going to show you once you have these settings, you want to come down here, make sure you've got individual files selected. And there's two at a minimum. You want these two, so you want to select Quartus Prime and just click on this download arrow, and the same for the Model Sim Intel FPGA edition. You want to download that as well. Now, if you have actual hardware that you want to run your design on, you can select devices. If it were me, I would be selecting the Max 10 FPGA device support. So there's basically three things you need to download. Now, if you don't have an account with Intel, you'll need to create an account with them, but it's free to do that. So you don't have to give them credit card number or anything like that. So it's a free account. But that's the main thing, is you want to get these three files, and they're fairly large. This is 1.5 gigabytes. This one's not quite 1 gigabyte, and the device file is about 330 megabytes. So they're fairly large. But I just wanted to show you, where to go, and the settings here that you need to select, and then make sure that you download. If you're not going to use hardware, then at a minimum, just download the Quartus Prime and the Model Sim Intel FPGA edition. Once they've downloaded, you should have files that look like here. So if you look here, these top three files here, I've got a Max 10 QDZ file type. This is for the actual hardware device, but the main ones you want are, if you're not going to be using the hardware, is Model Sim Setup and Quartus Lite Setup. And then you would just run these like you normally, run for executing to install software. However, you only need to basically run the Quartus Lite setup because it'll take care of doing the other stuff. So once you finish Quartus Lite setup, it will have already set up Model Sim, and if you had hardware, it would have set up that device. So anyway, the point is, when you download the software, you should have either these two files or these three files, and then just double click on the Quartus Lite setup, and it will install it for you. So that's all there is to it. Let me show you. Let's see. When you do run the install, okay, you'll see it here when you basically start running to install the software. it's already got pre-checked everything you need. So it's got the Quartus Prime Lite edition checked. In this case, I installed a device, the Max 10 FPGA, and then it's also got the Model Sim Starter Edition. So this is everything. You don't need this last one checked. You just want the Starter Edition for the Model Sim. So just make sure that you see all of these check marked here, and this is when you first run the install, when you double click on that executable file. And the other thing is when it's finished, then basically when you launch the software, you want to make sure that you select Run the Quartus Prime software. You don't need to buy a license or add an IP license. So just check or just make sure this radio button selected, Run the Quartus Prime software, hit OK, and you may have to double click the Quartus icon. I think sometimes once you do that, you hit OK, you still have to go back and double click this again. So if you hit OK and the software doesn't launch, just go double click the desktop icon. It'll create that at the end of the installation. It's automatically check marked to create a desktop icon. Okay, so that's pretty much it. Hopefully that makes sense. And now let's get started. So we want to start with basically a truth table. And so I've got this truth table. So it's just a 4-input combinational logic circuit. My inputs are A, B, C, D. My output is Y. And there's really no necessarily any meaning to the colors. I just like colors, and in this case, I guess I just made the ones green and the zeros red. But I mean, really, there's no significance to the color coding. Okay, so here, this is it. So we've got 4 inputs, we got 16 rows, and these are our outputs, my Y output. So it's either got to be a 1 or a 0. Now, from the truth table, you could write out, you could write out by hand the either the sum of products or product of sums expressions directly from the truth table, but that would be pretty tedious and be a lot of logic there. So it's really better to use a Karnaugh map to simplify things. So let me zoom in here. All right, so this is the Karnaugh map for that truth table. You can see that I filled in the ones and zeros, and I've determined the Boolean expression from the Karnaugh map. And so here, actually here, looks like I was really intending to use color coding, although this black doesn't match this green, so something happened there. But anyway, if you can see here, like these 4 ones, I've done a wraparound here. So B bar, C bar is for this term, and then this horizontal row of 4, A and B are constants, so I've got AB here. And for this kind of purplish one, this would be BC, because those are the terms that aren't changing. And then for this kind of light orange, this is BD here. So this is just coming directly from the truth table, from what I'm showing you here, the truth table, going to the Karnaugh map. And really what we're after is getting the Boolean expression. And so this is the simplified, Boolean expression from the Karnaugh map. Okay, so now we're ready to actually create our design. And we're going to do this in VHDL. If you were to do, you could do schematic capture in Quartus. And so that would look something like this, where you basically have your, your basic logic gates, and then you've got your inputs and your output. But I'm not going to show you how to do the schematic capture in this video. You certainly can do that within Quartus, but I'm going to focus on the HDL implementation. All right, so let's go run Quartus. So it creates this desktop icon here. So see, this is version 19.1. Okay, so this comes up here, and you just create a new project. Okay, and what I'm going to do, just to kind of keep things contained here, I'm going to go ahead and just create a folder. So I'm going to go into this video subfolder, and I'm just going to create a new folder, and we'll call this tutorial folder. That way I can put my project inside that folder. It just kind of makes it nice. It's, it's contained there within a single folder there. So I'm going to go to New Project Wizard, or you could go to File, New Project Wizard. So either way. So if you click on New Project Wizard, you're going to go through a series of windows here. And so the first one's just an introduction window, so you can just go ahead and click Next. Now this says, what is the working directory for this project? And so this is what I just showed you, where I created that new folder. So I'm going to go to here and tutorial. So I'm going to put it in the tutorial folder, and I'm going to call this logic circuit. All right, and so we've got that set up. So next, I'm just going to leave it as an empty project. I'm not going to add any files because I'm going to go ahead and just create the HDL file. So we'll hit next. Now, if you were going to use hardware, you need to select your device here. So like in this video, I'm not going to actually get to programming the device, but if you had the hardware, you would just come down here and select whatever device. But I'm just going to skip over this because I want to focus on the simulation and not the actual programming of the hardware. Next. Now here for simulation, make sure that you choose Model Sim Altera. So make sure you choose Model Sim Altera. And you can do either Verilog, or it looks like there's one called System Verilog, but VHDL. So I'm going to do VHDL for this tutorial. But you do have, the option of doing Verilog as well. Next, and that's it. Finish. Okay. So that will create the project. Okay. And it's called Logic Circuit, because that's what I called it. Now, at this point, I don't actually have any files. So all I've done is actually created the project, but there aren't any files in there. Okay, so what I want to do is create an HDL file. So we go to File. Now, this time we just do New. We're not going to do New Project Wizard because we've already created the project. We're just going to do New, and we're going to do VHDL file. If you were doing Verilog, you could do Verilog HDL file. And so we got VHDL file, hit OK. And then we've got basically an editor. Okay. Now I've already gone ahead and created the file, which is here. So I am just going to copy and paste my HDL file directly into the editor. Now notice it calls it VHDL1, which is really not what we want to call it. We'd really like it to match this project name, this logic circuit. So what I'm going to do is when you hit save, it'll prompt you for the file name. And actually, by default, it's giving us the logic circuit, which is what I wanted. And it's a VHDL file. And this add file to current project is already selected. So hit save. And now when we go to files, see under files, we've now got the actual VHDL file. And let me close out this window here just to give us more real estate here on the screen. And this is it. So this is just a really simple implementation of a logic function. I've got some comments. The way you do comments is use 2 dashes. So I just put some comments here. Now the 3 things you really want to have in your HDL, for at least for VHDL, you want to have a library section, you have an entity section, and you have an architecture section. Okay, and inside my architecture, I've actually got a process here for implementing the logic. Okay, so the library is just basically whatever you need to include. For something like this, we really probably just need, standard logic 1164. That'll be fine for this simple example. The entity is the I/O. So all the inputs and outputs. So if we go back to the truth table, remember A, B, C, and D are the inputs, Y is the output, okay? And so A, B, C, and D are inputs, and then Y is the output. And then the architecture contains the actual functionality. So the architecture is going to contain the actual Boolean expression. And as you can see, that's exactly what I have here. So I've got Y gets assigned not B, ANDed with not C, and then ORed with A and B, ORed with B and C, ORed with B and D. And that's it. I put these signals, these A, B, C, D, inside what's called the sensitivity list of the process. And all that really means is that when the simulation's running, whenever any of these 4 variables change value, then this process will be executed. So it'll update Y, which is what we want. Anytime your inputs change, you want to update your output. So that's exactly what we want. And that's it. That's all there is to this simple example here. So the way to compile it and synthesize it is right here where it says compile design. So if you double click on compile design, it's going to run through the steps of compiling, and then it's going to do some other stuff here. But the main thing you're really looking for, you want to get all green check marks on this side. So if you get all green check marks, then you're good to go. And there it is. We got all green check marks. So at this point, the design has actually been compiled and synthesized. And just to kind of show you, if you go under analysis and synthesis, go to Netlist Viewers. And under Netlist Viewers, this is pretty cool because you can see the actual RTL and the technology map. So if you double click on RTL, this is going to show you the actual RTL. So this is the gate level representation. Okay, and so it took the VHDL and basically created this schematic. And if you look back at our Carnot map, we've got B bar, C bar. So let's see. So we've got B bar, C bar, which is this third AND gate. And the other terms we had were A, B, B, C, and BD. So we've got BD up here, and we've got BC here, and so we've got A, B on the bottom AND gate. And then these all get ORed to go to the output. Okay, so like I said, you could have drawn this, you could have done schematic capture, like I showed. I guess I already closed that out, but I had shown you the oh, LC, there it is. So I'd shown you the actual logic circuit. You know, you could have drawn this out, but you know, by doing it in the HDL, when we ran through that compile process, it basically synthesized the gates, or synthesized the HDL into actual logic gates. And what the technology map, this is how Quartus, or the it's actually implemented in the FPGA. So here you're not seeing actual gates. This is essentially it's really like a lookup table where it'll just take the inputs and then look up what the value should be and send it to the output. And so this is specific to the actual hardware. So think of the technology map is specific to the hardware, whereas the RTL is just kind of generic logic gates that you've probably seen before. Excuse me. Okay, so last thing we want to do is simulate this. So if we go to tools, options, you want to make sure under EDA tool options that you've got the path set up for ModelSim Altera. So it's probably going to look like this. It's going to be in the version directory, ModelSim ASE, and then it's this Win32 ALOEM file or directory. Excuse me. And so that's where you want to make sure that that path is set. All right, so for the last step, we go to Tools, Run Simulation Tool, RTL Simulation. It's going to bring up a new window. Okay. Now, when it brings this up, the default, if you want the default window, just go to Layout, Reset. And so this will give you the default. Okay. And you can see we've got a waveform window, we've got a library over here, we've got a transcript window. So really what you want to do is you want to go to RTL Work, expand that, and you can see this entity logic circuit, and that's what we want to simulate. So I'm going to double click on that. And when you do that, when you double click on it, it'll bring up this object panel, and these are going to be all the I/O, the entity variables. So A, B, C, and D are inputs, Y is an output. If you shift, left click, and then right click, add wave, you'll add these to the waveform. And I'm going to minimum or close out these other windows because I don't need them now. Okay. And now what we need to do is apply stimulus for the inputs. So I'm just gonna recreate the truth table. So if I select the A input, right click and do clock, and these are in picoseconds. So um, which is really fast. So what I'm going to do, I'm just going to set this to 10,000 picoseconds for the period, which would be 10 nanoseconds. And I'm going to make sure the first edge is going to be falling. So I'm going to make sure the period's 10,000 and then the first edge is falling. Hit OK. And you can see down here in the transcript window, it basically shows the command. Now for B, we want to do the same thing, but we want to make the period to be half, so 5,000 falling. And then for C, we're going to make this one 2,500 falling. And for D, we'll make this 1,250 falling. So each time you go down to the next value, you want to make the period half, which is making the frequency 2 times. Right. Now, since I made the period 10 nanoseconds for this first value or first input, I'm just going to run. If I'm going to come down here into the transcript window and just run for 10 nanoseconds. Okay, and here's the waveform. Now, it's showing like the end of the waveform. So if you right click and do zoom full, you do zoom full, then it'll show you the entire 10 nanoseconds. And that's it. That's all there is to it. So you can verify that you have this cursor here, that you can verify the truth table. So if we go back and look at the truth table, you can see that for 0000 we get a 1, for 0001 we get a 1. So 0000 I got a 1, 0001 I got a 1, and then I get 3 zeros, 5 ones. So I've got 1, 2, 3 zeros on the output. Why? 1, 2, 3, 4, 5 ones, and then 2 zeros and 4 ones. So I got 1, 2 zeros here, and then I end with 1, 2, 3, 4 ones. Okay. The other thing you can do, since I've written the truth table, it's in binary order, is you can actually group. You hold down Shift, left click, you can group these into I'll just call it input, into input, and change the radix. Oops. Let's see what I did here. Combine signals. Maybe it's combine. Let's try that. Let's see, input. Okay, and let's change this to unsigned. Yeah, that's what I wanted. So now you can see that you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's kind of an easier way to kind of read the waveform. But the main thing here is, the logic circuit output Y. You want to verify that this output matches the values in your truth table. Okay, I think that's it for this video. Just wanted to give you a quick introduction to using Quartus Prime Lite to do HDL design and simulation. So I hope you found this helpful, and that's all for now.